All right, so the solar lab is really coming together here. So what I have here, the device under test here, is the Adafruit solar charger with the 5-volt booster. So you can connect a solar panel, a battery, and some load that takes 5 volts, and it will boost the battery voltage up to that 5 volts to supply that to supply whatever you're running. Probably a radio. So what's going on here? So the first thing to look at is that I have the battery. So this is the JST connector for the battery. It's coming out over here, and it's plugged into this power supply. But this is not just any power supply. This is a very special power supply. It's a 2-quadrant power supply, which means you can set a positive voltage, and then it can also sink a current. So right now it's getting, the current is negative 0.8 amps, and most power supplies, if you set a positive voltage, it expects there to be a positive current, or if you try to sink current into a normal power supply, it'll throw an error or break or whatever. But this one actually lets me sink current into it. And so why am I doing this? Because this is simulating a battery, right? So a battery is a voltage source that can sink a current, right? When you charge it, you're sinking a current. And then I can do things like change the voltage here and then see how how the system responds. Yeah, so moving on here, we can see that the right here the solar panel pin is connected up to this DC power supply. So it's just a standard DC power supply. This is simulating a solar panel that's producing 5 volts and almost an amp. So that's a in terms of LoRa radios, that's pretty, it's like a 5-watt board. So this is not a perfect solar panel simulator, right? This doesn't actually have an IV curve. So if I wanted to test, MPPT, I would need to have something that could actually simulate the IV curve, and this can't do it. But just for this demonstration, this is just fine. And then over here, connected up to the 5-volt out, I have a DC load. And what a DC load is it's basically a fancy heater, right? So it just draws in electricity on these terminals and turns it into heat. But it's fancy because I can actually set, I can set a constant current. I can say I want you to, try to draw, 100 milliamps or whatever from whatever I connect to you. So right now I have it set to 50 milliamps. So this is to simulate like a radio that's being powered from this board. You might imagine the radio draws, I don't know, maybe it draws 50 milliamps while it's idle. Okay, so what things can I learn from this? So here's an interesting thing I just found out, is that this board says it can take up to a 17-volt solar panel, but let's go ahead and see what happens if we crank up the voltage here. So I'm going to simulate the solar panel. Suddenly it gets really sunny and it's producing a lot more power, so the voltage is climbing, and keep an eye over here. Right now it's consuming about an amp. Oh, and there we go. Look, it's already falling. So I'm going to keep cranking up the cranking up the voltage, and we'll see what happens to the amps. Now we're at 6 volts and it's drawing much less. Now let's just crank it all the way up. All right, so now we're at, I think this only goes up to like 17 volts, this power supply. So now we're up at almost 18 volts, and the board is drawing much less current. It was drawing almost an amp before, now it's like 50 milliamps or something. And you might, so what's going on there? It seems like something weird is happening. You might think that, oh well, since the voltage went way up, it's going to draw less amps to draw, to sort of draw an equal amount of power. But if we go over and look at the battery, we'll see that's actually not what's happening here. So if we go look at the battery, we see that the charge current has dropped to basically 0. Right, so this 0.0002 amps is basically noise. So the battery is not being charged anymore after the voltage on the solar panel went up. So what's going on here? So this chip, it's a BQ25185, which is like some TI chip. And the important thing about it is that it has a linear voltage regulator in it. So when the power is drawn from the solar panel, there's a linear voltage regulator to produce the charge the charge current to the battery. And the thing about a linear regulator is that it's kind of like a fancy resistor, really. Like, and what I mean by that is that if the battery is at 3 volts and the panel is at 17 volts, that difference in voltage, that dropout, it's called the dropout voltage, needs to be just basically burned off as heat. That's how it regulates the voltage to the battery, is it just burns that difference off as heat. And what's happening here is that the chip, this tiny little chip, you can't even see it. It's like, tiny little surface mount thing, isn't able to actually burn off that much heat. So it thermally throttles. And if the difference is so great, it basically just turns off. And now the battery is no longer being charged. And what's interesting is, if you have like a switch mode power supply, it would be able to sort of handle that better. And there are solar charging chips that have both a buck and a boost built into the chip itself, so it can do that regulation much more efficiently. Then if we come over here and look at the load here, we'll see that actually it's doing just fine at 5 volts, and it's still drawing 50 milliamps. So that part of the chip appears to be unaffected there. So your radio will still run when it's in this state, but your battery is not getting charged. Actually, another thing that's occurred to me is that it's also not drawing any current from the battery, which is kind of interesting. So it seems like the chip has sort of switched entirely over to supplying the load. So I'll have to think about why that is. I actually don't know off the top of my head. But anyway, yeah, that is the first, interesting result from the solar lab, I guess, is that, I think the takeaway here is that the solar panel choice actually matters a lot. You might think the board says I can plug in a 17 volt solar panel, so I'm going to plug in the biggest panel I can to try to harvest the most energy. But actually, in this case, it completely backfires because the chip is actually sort of overloaded. It's thermally throttling, and it's not actually charging the battery at all anymore. So there you have it.